And hello, everyone. I'd like to welcome you to today's e-showcase, Advantages of Using Improved Ultrasonic Metering in Water and Wastewater Applications. I'd like to thank today's sponsor, FLEXIM Americas Corporation, for sponsoring today's event. I also have the pleasure of introducing today's presenter, John Van Nostrand. John is a Southeast Regional and Municipal Manager at FLEXIM Americas Corporation in Edgewood, New York. He brings 30 years of industry experience in various roles, including service, sales, marketing, and management. Starting his career in the nuclear Navy as a metrology specialist, he later earned his bachelor's degree in business management and has experience with many products and applications in the controls industry. So without further ado, John, I'm going to hand the presentation over to you.
Thank you, Regina. And I'm going to share my screen here. Make sure I get the right one. Give me 1 second. All right, I hope everyone can see the screen. Great. So we'll jump right in. And we're going to talk a little bit today about where we are and what's influencing the water and wastewater market and some common metering technologies, and we'll touch a little bit about FLEXIM and recent ultrasonic technology developments, and then we'll talk about some successful water and wastewater applications. So first of all, I'd just like to mention that due to the COVID-19 economic shutdown, many utilities have seen the effects of the pandemic. And of the country's roughly 50,000 public water systems, they'll all be affected in some way. The loss of jobs related to loss in tax revenue and widespread closure of restaurants and manufacturing facilities, theaters, dentist offices, universities, will not only reverberate in the job reports, but the shutdown also has an immediate and potentially long-lasting consequences on water utilities across America. Many utilities are already operating under newly imposed constraints. Because water is essential for hand washing and hygiene, hundreds of utilities have said they would not turn off the water to customers who are not paying their bill or paying their bill late. So it is affecting all of the utilities in some way or another. Additionally, with only 3% of the world's water available for consumption, regulation and drought are driving the need for even more accurate flow measurement in the utility. From point source to the final effluent, there's a growing need to be more precise with the accounting of water. This is equally important on the wastewater side. We don't often think about it, but here in the U.S., we're lucky to get a shower every day, even many of those who are under drought conditions. So there are parts of the world where, petroleum is far less expensive here, and water is nearly as expensive as gasoline in some parts of the country as it is in the United States. So we're kind of lucky in the U.S., and I think we've mostly realized that. In the past 12 months, the U.S. public water and sewer construction spend was about $43 billion. So there's definitely a lot going on as far as new construction in the water and wastewater market segment. I just want to give you a quick overview about FLEXIM. We're headquartered in Berlin, Germany, with 16 subsidiaries worldwide. FLEXIM started in 1990 with 4 partners and has grown to over $100 million in sales annually. There are more than 70,000 FLEXIM flow meters in service today and about 450 direct employees worldwide, not including our local representatives throughout the United States. FLEXIM Americas is a wholly owned subsidiary FLEXIM is based in Long Island, New York, where we assemble, test, and service the equipment for North America, and we expect to ship more than 2,500 flow meters from our New York facility this year. So we manufacture a number of different meters, and there are 4 series, and the 6th series are portable meters, and they are to be carried out in the field for spot checking, temporary service, and meter verification and calibration of other meters. The permanent meters are the 5 series and the 7 series and the 8 series are designed for Class 1 Div 1 locations. Not very common in water and wastewater applications, but sometimes we'll see those in collection systems. FLEXIM also manufactures a line of concentration meters. These meters can be used to measure concentration of a particular chemical, say for example, sodium hypochlorite. If you wanted to know the exact strength of sodium hypochlorite, we can do that from outside the pipe. We clamp onto the outside of the pipe and we can measure the sound speed, correlate that with temperature, and we can give you an accurate measurement of the concentration of sodium hypochlorite. We also manufacture a process refractometer that has a wetted sensor. It's not very commonly used in the water wastewater market. However, it is something that we offer. Another unique thing that FLEXIM does is remote support. We offer a tablet where a technician can be in front of the meter with a hotspot, and a FLEXIM representative can assist them from any remote location. This came about during the COVID isolation period and has proven to be an effective tool. So 2 common methods for measuring flow are primary elements and magnetic flow meters. Primary elements are often used in clean water applications, while magnetic flow meters, although they started out in dirty liquids, are now commonplace in clean water as well. Let's take a little closer look. First, the primary elements, or DP flow meters as they're often known. Figure 1 is an orifice plate, and this is the most simplistic and least expensive type of primary element. The orifice plate is used less often due to the fact that it has a large pressure drop that's needed to measure. Flow nozzles and venturis are in the same category, and they're all governed by ASME MFC 3M. So figure 2 is more common in the water market. It's a venturi tube and it has less pressure drop, but it's very expensive and it's custom made for the application. This picture in the lower right illustrates a 36-inch venturi. So according to ASME code, there are 3 huge limitations when using these devices. A minimum velocity of about 1/3 of the flow range is required in order to measure accurately. So these meters have a turn down of about 4-to-1, and the accuracy of the primary device is plus or minus 1%, not including the transmitter and installation errors. These can be really a big deal when it comes to impulse lines and head losses from the transmitter location to where the venturi is. And then, of course, the square root law has to also be considered, which we'll touch on a little bit more here. So the primary element itself has a fixed error that cannot be less than 1% as per ASME. The transmitter uncertainty is an addition to that error. So this is a best fit picture that illustrates a typical accuracy. It's called the best fit curve for a DP transmitter that has a range of 0 to 10 inches of water, which is quite common. In the red, you can see the ratio of DP to the flow is 1 at 100% of the span. So it's nearly perfect. 1, and if you take the square root, that's shown there in red, the square root of 1 is 1. So it's most accurate at 100%. At 50% of the flow range, the DP is 1/4 of the span. So you see that 1/2 and squared equals 1/4 of the DP. And then at 33% of the range, the DP is 1/9 of the transmitter span. This is the effect of the square root law. And this is why the orifice plate only has a turn down of 4-to-1. And believe me, 4-to-1 can be pushing it. It's really closer around 3-to-1 once you consider vibration, process noise, transmitter dampening are factored in. It's nearly impossible for the transmitter to measure below 25% of the span while using the square root extraction mode. This is why many applications have 2 transmitters stacked, and they span one transmitter for the very low range and then get a fresh start when the square root law gets into those low flow conditions. So with a magmeter, it's a little bit different. A magmeter works on the principle of Faraday's law, and that means that when a conductive liquid flows through the magnetic field, which is created in the spool, voltage is induced, and that voltage is proportional to the velocity of the flow. So there are two electrodes that are mounted on opposite sides inside of the flow process. They protrude into the flow process. And these two electrodes are connected to an electronic input circuit, which processes the signal and in turn feeds it to a microprocessor. The microprocessor then calculates the volumetric flow. The two electrodes must be completely isolated from the process by means of a liner, and the meter must be grounded to the earth with steel rings, cable, and grounding rods, etc., especially if there's any plastic piping. Like all flow meters, the pipe must remain full of liquid. The pipe size reduction that you see here is very common for magmeters because they want to increase the velocity through the meter. This also increases pressure drop and can increase pumping cost. We're going to talk a little bit more about that in a moment. Because the voltage that's created as the media passes through the magnetic field, the velocity of the media becomes very important, which is often why they put a reduced bore in the magmeter, because we want to increase that velocity. So the sweet spot for a magmeter is from 3 to 33 feet per second. But if you take a look below 3 feet per second, you can see the meter will still read. However, the accuracy does drop off. It becomes like a bell curve, and the lower you get below that sweet spot, the more inaccurate the meter can become. So this illustration shows a meter that was tested at the University of Utah. Now let's talk about innovations in ultrasonics and what FLEXIM is manufacturing today. In the past, there have been a lot of people that use ultrasonics with mixed experience, and largely because the old days they used the Doppler technique, where today we use a transit time technique. And although we're capable of measuring in Doppler, we tend to use transit time for almost everything these days because they're so much more reliable and more accurate with a lot of technology improvements, which we'll go into. So technology has always assisted us with the pursuit of our goals. Changes in technology results in changes in how we do things. FLEXIM's state-of-the-art metering systems have made it possible to achieve your resource management goals in water and wastewater measurements where other meters have fallen short. So one of the unique things that we do is we measure the sound speed of the media when we install a FLEXIM meter. Now we can accurately correlate the sound speed with the water temperature in drinking water distribution systems by calibrating the sound speed to the temperature of the water. And this is done by taking a sample of the water and inputting that value into the meter. Once it's calibrated, the meter will accurately report the temperature as it relates to changes in the sound speed. So this is unique to FLEXIM because our sound speed measurement capabilities are extremely accurate. So under flowing conditions from outside the pipe, we correlate the sound speed of the media to the temperature of the media. And when the temperature changes, we report that. And that's about plus or minus 0.35 degrees F. So we not only get an accurate flow measurement, but we can also correlate the temperature and report that too. That's becoming increasingly important, especially with biological growth and also predicting how much hypochlorite might be necessary to treat the water. So FLEXIM strength is not only being non-intrusive, but also measuring very low velocities or fast-moving media. Our ultrasonic technology is able to do extremely low velocity or extremely fast-moving velocities. So even with low-moving velocities, we can detect down to 0.03 feet per second, and with a specially calibrated meter, 0.003 feet per second. So as I mentioned, we can measure temperature from outside the pipe. This can help predict in the biogrowth. Temperature may also be of particular interest for those, like I said, with chloramines for disinfection and the amount of trihalomethanes that are present in the water. If you have an application specific to that, I'd sure like to know about it because I'm collecting data in that regard. So the way the meter works is we use a piezoelectric crystal, and that's inside the transducer, and we create an ultrasonic wave, and this rings to the range of about 300 kilohertz to 2 megahertz, depending on the transducer selection. We go much, much lower for tough applications like precast cement pipe. One thing that's worth noting is that FLEXIM uses propagation voltage of 40 volts, which is about twice our competitor. So we get a very strong signal and a very clean signal through the pipe. We're also capable of measuring with Doppler. We have the capability of doing that, and we can switch from transit time to Doppler if needed, both measurements using the same transducer. But like I said, it's not that common that we need to do that. So FLEXIM can even measure steam on low pressure and high pressure applications. For low pressure applications, we use a transit time method, as I just explained. For high pressure steam applications, we use a method called a correlation method, or CFM for short. I'm not going to talk about it too much because it's not that common in water wastewater applications, but it's worthy of mentioning because FLEXIM is the only company that can do this. High pressure, high temperature steam. So there are a number of factors that have helped FLEXIM become successful, and these are things that set us apart from others. And this is things that no one else does. For example, we use a coupling compound and a coupling pad rather than grease. If you've ever used ultrasonics before, you know you go out and you grease the transducers to the pipe, and after a while that grease gets kind of dirty and cakey, or it gets washed out, or it melts away, and then there's no signal. So you have to go back and recouple. No longer do you have to do that. With the FLEXIM meter, it's intended to be that you set it and forget it. We calibrate every pair of transducers that leaves the factory. That means that you don't have to start the meter up and obtain zero flow to do a field calibration. Anyone that tells you don't need to do that doesn't really understand what's going on in the pipe, because it is very important that you obtain zero flow, because these transducers, even though they operate on the same frequency, they have their own signature. There are crystals inside the transducers, and these are like diamonds. And you can cut them to the same size and you can weigh them to the same weight, but each has its own individual signature. So the differences between those up and downstream transducers need to be canceled, and that's done with calibration. So we do that at the factory, and every pair of transducers that we ship has that calibration certificate, as well as the meter having its own calibration certificate. Another thing that we do is we match those transducers, the crystals. So we like to call that a wetting. We have a lot of wettings at FLEXIM. That just means that we're matching the upstream and downstream crystals inside the transducers to ensure the tightest accuracy possible. We integrate the cables in the mounting so that there's a robust mounting solution, and they're industrially hardened, and there's no worry about how to connect the transducer cables, whether it be upstream, downstream, and so on. And then again, we also offer, like I said before, we have the capability of measuring steam. We can also measure gas, and we do that by offering a variety of transducers like lamb wave and shear wave with 1 meter. That means that you can measure liquids and gases, or Doppler, or even steam, all with 1 meter. So we temperature compensate every pair of transducers, and that means that the temperature compensation circuit nullifies any error that would otherwise show up as drift in the measurement. This enables us to get a very stable reading across the entire flow range, including a very stable 0 point. And the meters are bidirectional. They can measure forward or backward. I want to talk a little bit about that temperature compensation circuit. I like to show this because it illustrates the embedded RTD into the transducer block. As you see on the top of the slide there, it says embedded RTD. This is not part of the measurement process. Rather, it's used to temperature compensate the transducer to account for any thermal effects that might be going on from the sun beating down on the transducers, for example. The American Society of Engineers recognized the need for this compensation and wrote a standard called ASME MFC5M, and FLEXIM is the only one that meets that manufacturer's recommendation, prescribed recommendation. So here's what happens when the transducers are not compensated. And what we're looking at here are a FLEXIM transducer that's shown in blue, and a competitor transducer that's shown in the magenta color, and then the brown shows just the temperature overnight. And all we did was we clamped on a piece of pipe with the transducers mounted on it and left it overnight for a period of time, and this is the result. We saw drift in the measurement from our competitor. And this is because of not having the temperature compensation circuit. So then we took it a step further and we thought, well, let's put it in a controlled environment. Let's put it in an oven and control the temperature to see if that zero fluctuation makes a difference. Here's what we learned. We learned that this is the FLEXIM meter, and what we're seeing here is the blue line shown as our 0 point, where the green and the red shown are two major competitors. And you can see over time that the meters drift while the FLEXIM meter remains nice and solid. And if you take a look at what that drift translates to, it shows 0.1 feet per second on one meter and 0.07 on another. And that on a 6-inch pipe is either 6 or 9 gallons per minute, respectively. So it's quite significant, especially over time. Imagine over 30 days. Another amazing technology difference with FLEXIM clamp-on meters is the digital signal processing. Here are a leading brand and how they do it. And what they do is they digitally impose a marker on the sinusoidal waveform. And this is what that sinusoidal waveform looks like. And this is happening multiple times per second. And through the electronics, this mark is statistically placed at the highest peak-to-peak waveform, and the mark is called the zero crossover. There is an electronic detection window where that digital mark should appear. So if there are 100 digital marks that are sent and 50 are received, the math is easy enough, 50% signal strength. And sometimes that digital mark can move based on the process conditions, like maybe the temperature of the transducer, for example, and it can move outside of that detection window, meaning that the signal is lost. Now you have a detection fault or signal loss or a red light or some other means to indicate that you've lost signal. The signal may still be there, but the meter just can't see it. So take a look at the FLEXIM technology. We place 8 digital marks on each sinusoidal waveform and count all of them because that detection envelope encompasses the entire signal. We're not looking for a little window for that to show up in. So we're not only have the entire signal strength, but we also measure the fidelity of the wave. So we're actually measuring the quality of the wave as well. So we count each of those digital marks. So FLEXIM uses twice the transmit voltage of other ultrasonic meters as well. So with a higher signal amplitude, we're able to measure on really tough pipes that would otherwise be impossible. For example, thick sludge lines, ductile iron cement line pipes, precast concrete pipes. We're able to do these tough applications that were otherwise not even considered for ultrasonic. So when you first start up the meter, we can look at the signal to correlated noise ratio, and that essentially gives us an indication that we've got a good transmit signal, and it's a great diagnostic tool for setting up the meter to ensure that we have stable measurement. I mentioned that we do calibrate every pair of transducers. Calibration is important. Our transducers are calibrated in a NIST traceable lab and under 17025 standards, and every meter gets a wet flow NIST traceable calibration to plus or minus to ensure that it's going to be plus or minus 1% in your application. So that's what you can expect taking a meter out of the box and putting it on your pipe from FLEXIM is plus or minus 1% with the repeatability of plus or minus 0.15%. So,
John, can I pop in just for a second? We've got a real quick question. Real quick question from Karen about paper mills. She says those seem to be tough. So what about paper mills?
So paper mills, it kind of depends on the application. We want to verify that the application is one that we've done. We've done many different types of liquor applications. That's a common metering point in a paper mill. So yes, I would certainly say it would be worth looking at the application for sure. So whenever we start the meter up, we verify that the meter is set up properly by measuring that sound speed that I mentioned earlier and ensure that it matches what we would expect it to be. So in this case, what we do with that very, very accurate sound speed measurement, what you're seeing on the screen here is a correlation of a particular chemical versus the sound speed. And so this is a sodium hypochlorite application, which has a sound speed, as you notice on the bottom, from 1425 to 1485 meters per second. So what we'll do is we'll set this up and we can calculate the concentration of sodium hypochlorite in this application. Here's what that looks like a little bit more specifically. So you see at different temperatures, the sound speed then changes slightly, and we correlate that temperature to the sound speed, and you can see each of the different color lines indicates a different temperature. And so we actually can calibrate that meter, set it up, and give you an actual value of what that sound speed should be at that temperature. We measure it and we report that value. So we give you a concentration value that is plus or minus 0.03% of weight. So we give you a very accurate measurement of the concentration value. That's just one of the things that we're capable of doing with the FLEXIM meter that other ultrasonic meters cannot do. So it's worthy of mentioning. And it's a very common application in the water market. I mentioned earlier that we use a robust armored cable. This is what it looks like. It's like a stainless steel braided cable. And the sense prom holds the calibration data. You see the calibration certificate here in the upper right-hand corner. That shows us the cal cert that you're going to get with the transducer. And these are portable transducers. So the sense prom that holds the data for the calibration is integrated into the cable. So when you plug that into any of your portable flow meters, that data is automatically going to load in, and there's nothing that needs to be done. It's a smart coupling of the transducers in the flow computer. Additionally, it shows the coupling pad here. This is what the coupling pad looks like versus the grease. So it's a set it and forget it. I also mentioned earlier that we use a couple of different styles of measurement, lamb wave versus shear wave. If you were to visualize the energy, the lamb wave, which is depicted at the top, is kind of more like a floodlight, where the shear wave is more like a spotlight. So we're focusing the energy. The lamb waves are typically used some chemical applications, and a lot of the time it will be gas applications, air measurement, compressed air, things like that. And the shear wave is for liquids. So some of the approvals that are important for the water market and wastewater market would be the calibration certificate for sure, and then the C750, which is the American Water Works standard for ultrasonic flow measurement. I'm very familiar with this because I'm on the subcommittee for the C750. And then also the ASME MFC 5M, which I mentioned earlier. That's the American Society of Engineers standard for clamp-on devices using temperature compensation. And again, FLEXIM is the only one that meets that. And we have many customer approvals because we have no meter left behind policy. And that basically means that we guarantee that the meter is going to work in the application for which it was intended, or we take it back. In the nearly 10 years that I've been with the company, I've only had to do that a few times. So I'm often asked, how do we go about doing that? And what we have is something called a FAST form, which is a FLEXIM application support tool. It's nothing more than a data sheet. We look at that data sheet that's completed, and we say, yes, we like the application. We've done it. We know we can do it well, and we certify it, and we guarantee it's going to work. Otherwise, one of the nice things about this technology is that we can go out in the field and test the application with a portable meter before we go any further, and we can determine that it's a good application. So we have very, very few meters that we ever have to worry about not working in the field. We always test them, or we have experience with them. So I'm also often asked if FLEXIM meets the NSF standard. The answer to that is basically no. We don't have to, because we clamp onto the outside of the pipe. None of our components actually touch the drinking water, so it's not concerning at all. So AWWA M36 is the handbook for water resource management, which we meet, and all of our ultrasonic meters cover the C750 for water and wastewater as well. So some of the applications, first I want to address the freshwater side, then I'll just talk a little bit about the wastewater. But from the production wells to the finishing section and all points in between, I'm really sorry. Alyssa, I gotta clean that. To include chemical injection of orthophosphates, for example, and sodium hypochlorite, FLEXIM offers the best chance for water balance as well. So any of these applications where you see an F in this diagram of a water plant is a great spot for a FLEXIM flow meter. Likewise, on the wastewater side, from the collections throughout the treatment process into the final effluent and all points in between, including chemical injections again, we have a lot of applications with dosing polymers, hypochlorite, and bisulfates. So any of these locations where you see the F is a great location for a FLEXIM flow meter. So I got to talk quickly because we're going to run out of time, but water loss has gone from being a headache to a migraine. And there's a lot of competition between utility companies and municipalities to be the best at resource management. And those who fall below the standard ranking might be considered poorly managed. The fact is that the pressure of the governing authority is becoming more and more increasing as time goes on, and water loss reduction is now being put in terms of dollars and cents rather than percentages. Additionally, the lead and copper rule that was first established in 1991 is now definitely in full force, and the copper and lead is a real big problem, and I don't need to go into a lot of the details about it, but the fact is it's estimated that it's affecting as many as 50,000 utilities across the country in some capacity. So injecting orthophosphate is one way to prevent this problem from growing. And what that does is that covers the Magmeter electrodes. So when you inject chemicals like orthophosphate, you see in this picture here, the blue line was a magnetic flow meter. In this case, it was a manganese coating, but orthophosphate has the exact same effect on it. And the FLEXIM meter just shows a nice steady flow where the Magmeter over time begins to show lower readings, as much as 50% of the actual reading. So it is a real problem. In this case, it was, like I said, manganese, and a lot of people don't realize this, but this is a mineral that is most commonly occurring, and it's an iron that it's attracted to it's basically got its own magnetic force. So it's attracted to any kind of metal, and it as a permanent magnet onto itself. So I'm going to go one more slide here to show you what that looks like under a microscope. So on the right here, on the lower right, you see these little particles. Well, these particles are charged with a north and south pole, and they actually stick to themselves. And what happens is on the inside of a magnetic flow meter, I mean, just think about it. The word magnetic is in the name. This coating coats the inside of a magnetic flow meter, and the relationship between the perceived accuracy and what they really are once they're installed, because of the iron content and chemicals that are injected, like to reduce the lead and copper, this accuracy is quite disparaging, and it can be as much as 50%. So that's a real concern and a major consideration for water users to think about. If you have any of iron in the water, manganese in the water, I always like to say, if you see red sidewalk, you've definitely got this problem. And also, if you're injecting chemicals for lead and copper, you definitely have this as a concern. Turn down is also a major one. Turn down refers to the operational range of a device versus what the meter is capable of measuring between the low range and the high range. So just to kind of give you an idea, we assist a lot of water utilities, and what we've learned is that most drinking water piping systems flow below 3 feet per second, even during peak demand. So off-peak times, the flow can diminish to velocities below 0.26 feet per second. Sometimes it even flows backwards. I've seen that before too. So with low flows like this, it's nearly impossible for conventional meters to capture the movement of the water. So off-peak times, your meters could be far less accurate than you think they are. So below 3 feet per second, the Magmeter particularly drops off. I've talked about that a little bit before. Now you couple this with the lead and copper regulation for those that are using, if you have alarm limits of below 15 parts per billion, that creates a whole new concern because you're putting corrosion inhibitors in the water, making your electrodes less sensitive than they should be. So that's a major concern as well. So with the ultrasonic clamp on, we have helped a lot of people. Like I said, we love doing it because we clamp right on the outside of the pipe and we accurately measure what's going through it. We can provide you concentration of some chemicals that you might use, as well as the temperature of the media. And we do that with a number of different meters. We have a whole family of meters that we can help you with. And again, they're all clamp on from the outside of the pipe, and we cover portable as well as dedicated. I'm going to jump right onto the portable meter here. These portable meters are terrific. Everything you need is in the case. It has a 2-channel meter, so you can put 2 different sets of transducers into it and measure 2 different locations, or you can measure averaging of 1, improving the accuracy. They have a 16-hour battery, multiple outputs, a data logger, software that comes with it. So there's a number of things that you're able to do with these meters. For example, the 401, the one that's green on the right-hand side here, comes in a Pelican case and has an additional battery that can do water loss studies for as long as a month at a time. It has a sleep function, so you can go to sleep and wake up and take readings at certain times to get your baselines and then go back to sleep. So the question often comes up about straight runs. How much straight run do we need? Now, there are a lot of concerns out there with old pipes where you don't have a lot of straight run. So we recommend that you have 10 diameters upstream and 5 downstream if possible. But if that's not attainable, there's something we can do to shorten a recommended distance. And we offer something called a profile correction, which is a correction factor based on empirical data that we've collected for many years, testing many applications. So we can actually take a radius of the bends ahead of the meter, the distance, and so on, and we can program that into the meter and put in the correction factor. So, and we can also use a couple of different styles of mounting. We can use direct mount, which typically requires the 10 and 5 diameters. Then reflect mount would require fewer diameters. And then if we used dual beam, meaning 2 sets of transducers averaging, or even 4 sets averaging, we can improve the accuracy greatly without that straight run. So I'd like to just show you what that mounting solution looks like. There's a very robust mounting hardware that we use to affix the transducers to the pipe, and that's often a concern when it comes to ultrasonics, but not with FLEXIM. We have a very good, robust mounting method. So there are many applications in water and wastewater, and FLEXIM fits them well, from production wells to water treatment, water distribution, sewage collection, sewage treatment, as well as I can go into some specifics here, and I've got a lot of data on these applications that I'd love to share with you. Chemical injection, cement-lined pipe, some old crusty pipes in a well field that are coated with manganese, water distribution systems, sewage collection. We've got applications where the pipes are buried directly into the ground or even left underwater. And again, very low flow conditions, as well as cement precast pipe and chemical injection and hypochlorite. So I don't have a lot of time to go into those specifically, but I did want you to get my email address so that if you have any questions, you can use the chat box as well as send me an email, and I'm happy to answer your questions.
All right. Perfect, John. Let's see. You've got quite a few questions in the chat. Let's see if we can just kind of get to as many as we can. So I'm going to go in the order that they were received. So the first one was, are the FLEXIM clamp-on flow measurement devices appropriate for insulated pipes, for example, in an oil refinery?
So that's a very good question. The insulation would have to be removed. We have to mount those transducers directly on the pipe. The answer is yes, it can be, but it's not as easy as putting it over the insulation. And often if it's insulated, it's often very, very high temperature. So it's worthy to mention that we can go up to 1100 degrees Fahrenheit with our installation hardware that we offer. So there's nothing that we're afraid of when it comes to measuring in a refinery.
All right, great. Can we also receive the temperature signal via HART?
Yes, you can. That's a very good question as well. We do offer HART, and that parameter is available on the HART string.
All right, great. What is the lowest concentration of sodium hypochlorite in water that can be detected with the FLEXIM meter? Less than 1 to 5 ppm?
Yes. Yes, 1 to 5 ppm is certainly possible.
All right, perfect. How does a FLEXIM meter or any meter that measures velocity account for fouled pipes when converting a velocity reader, what you measure to a flow, what you want to know?
Yeah, that's a very good question, and I can talk about that for quite a while. The short answer is there's no compensation for any meter that I'm aware of. You can't see the fouling on the inside of the pipe, so you have to deal with what you got, and often that is a problem. So when it gets to be really bad, you remember I mentioned that we look for that sound speed of the media. If that sound speed doesn't closely match what we expect it to be, we can then play with that wall thickness to tune that in. So there is some compensation that we can do, but it's kind of a fudgy number. So there's really, the only way to ensure that you're going to have a perfect measurement is to put in a nice new section of pipe.
Okay.
I hope that answers your question.
All right. What's the accuracy in flow measurement in WW with high suspended solids?
So we're still at 1%, regardless of the solids. If we set up and we set the meter up properly, we can expect to see plus or minus 1% with the repeatability of plus or minus 0.15%. And that's of the reading, not the span.
Okay. Are the portable meters available for rent instead of purchase?
Yes, they are. In fact, we have a rental group that we can ship meters directly to you, and there is a process for which we follow. Just call your local salesperson. They'll be able to help you with that.
Okay, great. And one last question. How does the ultrasonic cost compare to Magmeter?
That's a good question. It's always a concern. Anything below about 6 inches, we're going to be looking at a very close cost competitiveness. But when you get above 6 inches, the ultrasonic becomes very, very cost effective because the price doesn't change with size like it does with a Magmeter.
All right. And that looks like that is the last question. And that actually brings us to the end of our presentation. So this was great. Thank you so much, John. This actually brings us to the end of our presentation. So I want to take this time to thank you and to also thank our sponsor, FLEXIM, for sponsoring today's event. This actually concludes today's e-showcase. Thank you all for attending. The recording will be available at wefbuyersguide.wef.org. We will send all registrants an email tomorrow with that link. And please visit our event calendar to sign up for future webcasts.